Okay, so the next team in session 2 is Mistress Margaret.
How you doing? I'm Todd Baldwin. I'm Southeast Territory Manager for Vivo. I have my fun group here with me. We're going to discuss Mistress Margaret. The group I have with me is Mr. Randy Hoffer. He actually is the manager that operates that plant. Mike Snodgrass, who is pretty much the brains of everything we do. If we have a question, we call him because he usually tells us if we're right, wrong, or indifferent. And Mr. Frank Blocky, he's the technician that usually goes out, and when I say I don't want to get dirty, he usually puts on his little white suit and jumps in the basins. So, again, there we are. I'm going to hand the microphone over to Mr. Randy Hoffer right now. He's going to briefly go through some of the background information and get this thing rolling.
Thank you, Todd. My name is Randy Hoffer. I'm little town Sneeds Ferry, North Carolina. And about 1987, we had our initial plant was built. It was a lagoon system, and it has 2 pumps, and it has 2 buttons. Very simple process. You spray it out on the field. 2009, we were bought by Plurus. Plurus, we constructed this plant that we currently have. It's a 1 MGD plant, and we did that in 2011. Started out great. Membranes were good. Everything was going. And about 6 months into it, we ended up problem after problem after problem. A lot of it was electrical. But as time went on, as you can see, there's different things that was going as from the beach and all the way through there is we have 98 duplex stations. Most of what we have, being right on the beach, we're flat, so we have a lot of pumps. Being 98 duplex stations, we also have 700 simplex stations. Those are also grinder pumps. At the time, we didn't realize, as what Dennis was saying, find the root of the problem. You got to start with the root problem, and you can get that fixed, then it will fix 2 or 3 other issues. We started out with the Kubota membranes, and we were having issues with those, with the silica. We were constantly cleaning with the fouling. We had the damaged sheets. We ended up having to pull those out. We changed them out. And with doing all this, and I'll kind of throw in there as my wife coming to me one night, I'm going over there, it's 10:30, 11:30 at night. She's like, it's another woman, isn't it? I was like, no, dear, it's not another woman. What's her name? I was like, well, come on and get in the truck. I'll introduce you guys. We got over there, and that was her. I showed her the HMI. I was like, no, just sit there for 2 or 3 hours because this is what we do. And we make changes, and we make changes, and we make changes. That was her one and only trip. Her and Margaret don't get along. So.
Hence the name Mistress Margaret.
Yeah. So, but anyhow, I'm safe. She lets me go over there because they pay me. So, but we slowly made the changes. With the change in we retrofit with the new membranes. They work really good. We are running about 400,000 gallons a day through it because we've only outfitted only 500,000 gallons. We're only running one side. So we're running 80 to 90% constantly through there.
Again, as he just gave you a good background of some of the problems they have. Initially, when all this was going on, we were able to increase the capacity back to what their design was as 0.15. The first 6 months, CIPs went really well. I mean, they only did like 2. Everything responded really well. Everything looked really good. We did see, after a little while, a decline in performance. Initially, and this is where the next slide comes up, where we assume a lot of things. We assumed it was due to a storm event because of a lot of flooding. Capacity went down, everything. Nothing we did worked. We talked several times on CIPs, never could get anything going. Everything we were doing just seemed like it was going backwards. And again, that's where we were assuming we knew what was going on. We were assuming this was the problem. And again, this is why we put this slide in there, because everything requiring the fewest assumptions is most likely to be correct. Well, we never were going that direction. We were going the other way. And that's where we stepped in, Mike stepped in, helped. We started looking and realized that based on the data, we went through and looked at the data. As you can tell, here we are thinking October, November is when we had the problem began. Actually, it began way back in May. If you look at the data here, you can see the downward slope, and nothing we did would recover it. So again, we were assuming, but we were wrong. Again, went back, looked at more data, CIP frequency. Before all of this happened, you can see very little CIPs were done between 15 and 6/23 of 2016. Then all of a sudden, the tail end of that year, you can see it's nothing but they were spending more time cleaning than they were producing water. And as you see, 16 to 8 was the ratio. Then enters Mr. Frank Blocky and Mr. Mike Snodgrass. They pretty much handled the rest of it for us.
All right, so where I came in at, came in to do the inspections and start collecting lab data to see what possibly was the effects of what was going on. So as you can see, we noticed a lot of scaling that was on some of the membranes. So I was able to cut a membrane up, send off some samples, and what came back, the foulant was found to be about 68% organic matter and 32% inorganic matter. And then upon actually doing the inspection, we saw there was a lot of ragging. So what the ragging did was it changed the air channeling, and that can lead to dewatering and reduce the CIP efficiency. So the next slide is going to talk about the gaps. As you see, there's some gaps in between the cartridges, and that's what the air caused the gaps to come out like that. And then the air was going in between the gaps versus in between the membranes. So as you can see, the gaps in the top left corner up there, and the fix of it was we had to bolt them together and close the gap so the air can come through the membranes versus the gaps in between the cartridges. So the root of the cause, of course, was the ragging issue was the actual root of the cause, and also the air scour was less. So that's what caused it to start dewatering, and then the CIP wasn't doing a very good job. So what we did was we brought in a skid, and this is what a CIP skid is, and we took the 3 worst operating membranes out of the plant, and we stuck them into the CIP with extensive cleanings and we did different type of the solutions, and then the soak times, as you can see. And I guess, Mike, you want to come in at?
So the first step that we really had to address, obviously, was with the ragging and dewatering. We had to close the gaps back up so we wouldn't have any more issues related to the air scour. Now, the second step that we needed to focus on was to actually clean the membranes and restore permeability. As we mentioned earlier in the presentation, we were doing cleans after clean after clean, but still not making any progress in terms of restoring the permeability. So we went with the approach with having the CIP pilot skid. We went with the approach thinking, okay, maybe we have a complex fouling matrix here where certain constituents or components can sort of mask one another, and you kind of have to slowly break it down layer by layer to get an overall effective clean. Sometimes when you have an issue like that, just a single clean, you won't really see much improvement. So we went with the approach that we were going to do a multiple step cleaning process and closely monitor the improvement in permeability with each different cleaning step so we could better learn what was fouling the membrane. So if you look in the upper left corner, that was the pilot cleaning study. So you look at the initial clean water permeability, it's pretty low. We did a chlorine clean, bumped it up a little bit, but still we're below where we want to be. Then we did an acid clean that made a nice big jump, and that's getting us back to the levels of where we want to be. And then we decided to follow that up with an additional chlorine clean, and it was only after that we really did see the type of recovery that we wanted to do. Once we collected all the pilot data, then we performed the same cleaning procedure on all the membranes in the basin. And as you can see, it followed the same pattern that we saw in the pilot, where we got initial bump with the bleach clean, We cleaned with acid, got an additional bump, but once we did that final bleach clean, it really got us back to where we wanted to be. So what this really allowed us to achieve is, on the left-hand side of the plot, you can see that's roughly the capacity that he was, or the permeability that the plant was at before we did the pilot study. We completed the pilot study, did all the cleaning on the basin per the results of the study, and you can see there's a pretty dramatic improvement in the permeability. So we did that initial full recovery clean on the basins, obviously huge improvement in membrane performance. Then some subsequent maintenance cleans after that really bumped us up and got us back to where we wanted to be. So here's looking at the plant capacity before and after the whole cleaning study. So obviously you can see much better overall capacity, and we were able to meet and also exceed what the design flow was. So it was really sort of a complex fouling matrix that we were dealing with within the membranes, and it took a different cleaning approach to recover the membranes and get the plant back where it needs to be.
We're going to touch base on the ragging problem that we had. Again, as I mentioned, with all the lift stations, all the grinder pumps, our screenings were just passing through the original the fine screen that we had. It was a 3mm screen. Now we purchased this one and we put it and installed that one. It was it's a dual screen. It actually goes from a 3 down to a 1mm. As those are going through there, it's like dissolving, coming through, and then it would build up on the side of the. Right here is where we're going through, and this is what we were getting out of there, the screening now. Have you seen the commercial, mypillow.com? That's where we send all that right there, so make sure you get those. It's working really well. We're really pleased with it. As you can tell from the screens from where we were to where we are right now, we're doing these about once a quarter as far as drawing it down. And, you know, we have the ability to do that because we have all that equipment on site. But, yeah, we're about every 3 or 4 months, we'll draw it down, clean it out. But we're finding out that, again, the root problem was at the very beginning, you know, your screenings. Because we can't go out and we can't change all the pumps. We can't go, you know, rehab all those things. But as you can see, that we're getting these once a week instead of, you know, now we're getting them once a day.
Well, again, based on what we were doing, we did root causes. We had assumptions. We went in. Everything that has been done between the CIPs with Frank and the pilot and Mike's feedback and what they've done with the screens on site, we've decreased our CIP by 5 times. They went from 16 cleans to 3 just in the last 12 months. That was all due to what we've done. We found a unique protocol where most people may do bleaches all year and do 1 acid. These guys do a bleach. If it does not recover or sustain, they do an acid, kicks it right back up, and then they start all over again with the bleach acid or acid bleach. Depends on what they see based on their data. As you see here, when we did it, average flux over the past 6 months has been 12.3 GFD with a 10.1 permeability. That's on the average. Their design is 11.6, so that tells you they're running capacity day in and day out. Every spot on the blue line where you see it dip and then come right back up, it looks closer than you think. And well, that a lot has to do with the operators that are sitting back there in that back corner. They won't say anything. They're hiding from us, but they're very proactive. They watch, they know the numbers we have to have or would like to stay above on permeability. So when they see that little bit of a dip, to them it's, hey, let's go ahead. It's not going to be that long. We'll go ahead and do the clean, get it right back up, and we can go home and sleep at night and have to worry about coming in tomorrow. So come in tomorrow and have to dig out something or get way worse. So again, saw the declining permeability, collected the data, found the root causes, came up collectively with a group. This wasn't a single person. This was a group. We got everybody involved. We came up with Pluris and Randy, his guys got involved. We came up with a solution. The result is consistently running capacity and design day in and day out. Check your assumptions. Again, we assumed. We were going the wrong way with our assumptions. Look at your data. Every MBR is different. You may clean once a year. Somebody else may clean 10 times a year. Are y'all any better or any worse? No, it's just every MBR is run differently. Find the root causes. This comes from my man, Mr. Randy Hoffer. No matter how unwilling it is to reveal itself or complicated the trail of clues becomes, there's an answer. It's just how deep you're willing to get into it and find it. Validate. Goes back to what Mr. Livingston was saying earlier, data, data, data. Use that data, find it, go to it, use it, you'll get a solution. And finally, this is my personal thing, and I'm going to jump off of it for people to get too inquisitive about it. But there's a couple of people in here that know what I'm saying. Never, ever, ever say the C word. I'm not going to say what the C word is. Y'all can talk amongst yourselves and think about it. There's a couple of people in here. Stephen knows. There's a couple of people in here that know what the C word is. You never say it. If you say it, you might as well just go ahead and call your wife and tell her you're going to spend the night with Mistress Margaret that night, because that's where you're going to be, is at the plant the rest of the night and probably the next 2 or 3 days. So, again, that's us.
Sorry, take a seat. Please sit down, gentlemen.
The CIP process utilized 2 different concentrations of bleach. Can you tell us why one was 10% and 12%?
No, if I recall, we prescribed the same bleach concentration. I think it was just more of what we were able to achieve when we were actually doing the clean. So it could have been, the stock solution strength may have changed over, because this was over, several day periods. So, or we just didn't get the same flow or some reason like that. But that was not intentional. They were both aimed at roughly the 0.3% bleach concentration.
And one thing to note, what makes this plant even more unique is the source water. Their pH coming into the plant's already up close to an 8. So when it comes out the permeate side, it's still close to an 8. So whereas you may have to use a 0.2% to get up to that 10.5 pH, they're using a 0.1 because they're already that high. So that was part of the challenges we had to go through and why we were able to work through this and get the protocol from bleach, or acid bleach, whatever they see deems necessary.
I have a question, actually. It's sort of like, believe me, of the people sitting on this, standing on this stage or sitting, I am the most ignorant here. So please don't feel even remotely intimidated. But what I was wondering is, you were obviously faced with the issue of not being able to recover membrane permeability. Not that unusual, but in your case, you seem to have an inorganic issue. You had quite a large amount of inorganic, and then you had ragging as well. Well, as far as I can see, permanent fouling will behave pretty much the same way as ragging or clogging in terms of you apply the clean and it doesn't work. So at what point did you sort of be able to somehow differentiate between like the permanent inorganic fouling and the ragging?
You want to answer that?
Well, first off, we fixed the ragging problem, and you still had the permeability issues.
Oh, is that way around? Okay.
And then the second point of that was when we were cleaning them, we had 10 units, and we were doing five units at a time. We were cleaning. Well, when you're cleaning that, it was only filling up 1 or 2 units. You weren't cleaning all 5 at a time.
Right.
So the 2 that are furthest away from the input, so 2 and 3 on the end of that, they weren't getting cleaned at all. So to rectify that was you clean each individual one. It takes longer process, because you have to do the same thing, but instead of separating into 2, we had to do it 10 times. So, and then because that way you can actually see which one, is 220, 250 gallons per unit per skid. So that's what we were filling them up with.
Okay, any other questions? Because again, frankly, I could go on all day pummeling these people with questions, but it would seem a bit unfair. Yes, sir.
In your stating, you said that you're still pulling your membranes down every 3 months now, visually checking them and inspecting before you do your cleaning, or are you doing the cleaning first? And did you fix the rag problem with the 2mm screen, or the 1mm screen, I guess?
Yes, yeah. The new screen that was installed fixed the ragging problem. It's a maintenance situation with us. We just we wanted to make sure, every 3 months, 4 months, we want to get in there. We have the time. I know a lot of you probably don't have the time to shut your plant down because we still have our lagoon system, so we could actually send the flow over to the lagoon system if we need to. A lot of you don't have that luxury. You're based on, I can only shut it down for 4 or 5 hours, and then we got to kick it back on. But yeah, it's an all-day process, but we think it's worth it to go down there and inspect them. And then we do a little bit of cleaning on them. We'll wash them out a little bit. Well, I say they get down in there now. So, No, that's just our maintenance program right now. Is we'll do it every 3 to 4 months.
And I think you at least intimated that the amount of screenings had increased by a factor of 7. You sort of said something like, yeah, that's a lot of screenings.
To answer your question, I don't know how quickly we went through it, but you can see this is actually raw data from them. We actually figured up, it took a month prior to this new screen being put in and them repairing the screen, doing what they need to do. It took a month to get about 30 cubic feet of material. Now they're doing it in a week. So that tells you the difference, how much ragging is being removed on top of what they're doing, just with the 3-month maintenance.
Okay, I mean, obvious question, does that have a huge impact on the OPEX, or would you just get a truck in once a week instead of once a month?
No, it's, we just take it and we'll empty that box and we just put it in the dumpster. I mean, it's just, it just dumps it once a week.
Okay.
So we're not, I mean, you know, we had to increase the size of the dumpster, of course, but I mean, they just, it's not a huge cost for us.
Right. I mean, but it's interesting for me. I mean, I'm obsessed with cost analysis. You know, I have the typical English car boot mentality. You do anything to try and save money. But it's an interesting thing as to whether it's worth investing in a possibly more expensive screen, and B, pay for the guy to come and collect the screenings more regularly, rather than have this constant intervention which you've all had to suffer as a result of allowing these fines to go through and hit the membrane and then cause the opening up of the channels and everything else. So clearly, I'm sure you're all as one saying, buy the screen. That would be your recommendation, I guess, right?
Yeah, it goes back to what we said.
Sorry, could you grab your...
Sorry, it goes back to what we said. It's data. We saw a problem, had the assumptions. Collectively, working with these guys, we found the problem. Screens was a part of it, but some of the inorganics we found in the water, the pHs of the water, the inappropriate air scour because of the ragging, and things like that led to it. So we were able to, it's kind of cool. We were able to really take a small plant in and mimic what we wanted to do with his plant to find the right combination. And once we found it, they were able to fix all these other things in conjunction based on what we found, and now that's made those operators back there in the left-hand corner made their life a lot easier.
Yeah, absolutely. Yeah.
And I also want to add, I mean, I feel like, you know, I've been to 4 of these workshops, and 2 of them I've been on this side of it, and I feel, you know, I'm the problem child. It just seems like, oh no, here we go again. But, you know, they have a good group here. You know, when I type in Ovivo in my phone, I have 31 different contacts. I was looking at it yesterday. And but they got a good base to pick from, and but we've had issues. There's no lying about that. But you know, we're building. We just constructed another one. It was about 2 years ago. We built that one, and we're looking to build another one in North Carolina to move forward.
One of your early slides talked about the improvement in man hours per week. One of the early slides. Are you going to address that later, or is now the time to tell us about it?
I think that might have been Dennis's presentation. Is that right? Man hours per week.
Yeah, that was Dennis.
Yeah,
That was about dewatering, right?
That was about dewatering.
Yeah. Clearly, it goes back to the thing I said earlier. You can always sort of invest in the extra labor to sort of solve these problems, but I imagine if you make the capital investment, then it's always going to pay off. It's just, obviously, it hurts the bank balance a little bit when you do that. But yeah, that was actually part of Dennis's presentation. Do you want to sort of respond to that at all? Or you might have to shout, unless you...
That was specifically referring to something called dewatering or clogging. So if there's an event, let's say there's insufficient air scour, filtration continues, then the solids build up between the plates or the sheets, that won't come out with a standard cleaning. So there can actually be physical cleaning to remove that material. And I was talking about, well, with the plates that we've used at many plants for many years, if that happens, it can take a long time to get the solids out in terms of man hours and man weeks. And with each generation of technology, the newer technology, that time has come down. So now it's closer to, say, a week to 2 weeks if that happens. It doesn't happen at every plant, and it doesn't happen repeatedly at the plants where it has occurred. So it's gone from 5 to 12 man weeks down to 1 to 2 man weeks, and our goal is to make it 0 weeks to prevent it in the first place. So not routine maintenance, it's just for a particular kind of event.
Are you going to present information so we can predict the manpower requirements for man day?
We will, actually Professor Judd will be talking about clogging and what can cause it, and then maybe at that time or as a wrap-up tomorrow we can get back to that question. It's a good question.
Thank you very much indeed, Dennis. Sorry to dump on you impromptu, but I think one of our speakers had an answer to that very question, sir. Okay.
You asked how long would it take to clean a unit? Or is that what you were talking about, like man hours?
How we might predict the manpower requirements for, say, various size plants?
It all depends on the number of units. Some other guys can probably back me. They may have different numbers, but I know personally a typical RW unit, RW size, the 515 models, it's usually going to take, from time you drain the basin, take it out, just the unit itself with regular 200 sheets. Time you drain the basin, take it out, clean it, put it back in, you're looking at 6 to 8 hours, usually 3 men, minimum.
Okay, well.
Or at least I've cleaned enough of them, that's how long it took each one when I've done them.
I keep forgetting I've got a microphone. You can put it right there on the desk.
You're the MC, I'm just a lowly life person.
Well, anyway, having taken a very sturdy grilling, I'd like you again to thank our team. That's, to get the names right, Todd, Randy, Frank, and Mike in the usual way. Thank you very much, guys. Okay.